Okay, this is the last file, and it is about memory because um, agent shows very interesting behavior in the previous if the codes in the previous code. You see prompt was like this. So all the sequence of calculation mentioned at once. But if the prompt gives part of calculation, then it didn't really remember the previous calculation. So that's why here agent memory comes in. It's important to remember the previous answer, previous tool output, and then use that previous output to do the following task. You'll see what I mean by that in the function. So this cell should be modified like as a tool we used. And here, well, everything is same except this memory part. So here, it didn't give all the computation at once. It first asked 3 plus 4, and it was okay. And the human message comes in again. I can multiply that by 2, which should be 7 by 2, 14. But it chooses random number and gives a wrong answer, which means the model really cannot retain the memory of previous output from the tool. So that's why in this code is about agent's memory. To keep the memory to make model have a memory of the previous output, we need this memory saver. So we define memory saver and provide thread ID. So this is how to give memory to the agent. It says configurable thread number 1, and then give a message, and before it runs the message, here this configuration is added in the model. So this React, yeah, this one is memory saver is used here. So when builder, which is a graph here, so graph is defined, and then graph is compiled with checkpointer with this memory saver. And so now the graph requires this variable as a configuration number and ask the same question. So add 3 and 4, that's 7. And now pass the configuration ID and ask the question. Then it correctly retrieves previous conversation and then multiply previous value by 2. Okay, 7 multiply that by 2. So 7, 2. Product of 3 and 4 multiplied by 2 is 12. So what we are gonna do is modify this tool, okay? And then we're not gonna give prompt at once. So we'll change the prompt, get source code of Tylenol, and then we ask to check compliance of Lipinski's rule of 5. So if we separate the prompt in the previous code, then in my testing, when I run this first, I get the smart code, and then I run the second prompt, it gives the output that I need a smart code or something. So as this file shows, if you define configuration with memory saver, then now you can split your prompt. So here the task is make your agent to remember the previous tool output. So even though user gives a prompt one by one, it should run and remember the previous output and give a final answer correctly, even though these prompts were given after this first one. So here you should give your first prompt and then give your second prompt, and if the agent works well, which means correctly checking the compliance of Lipinski Rule of 5. So this is the final tutorial. And if you think, this is all from my side. And if you think it's too easy, as I suggested before, maybe you can try to add more tools and test the agent if it can correctly find the tools, and also try to make the graph architecture more complicated and do the advanced task like a quantum mechanical calculation or molecular docking. That's it for this hands-on session.